aldehydes and ketones react with HCN, okay, to form hydroxynitrile. So we always start with a carbonyl compound reacting with HCN, okay, and they form hydroxynitriles. Now, this reaction uses a mechanism called nucleophilic addition. Okay, so here I have a diagram showing the mechanisms. Now I'm going to draw, okay, on a white canvas to show you step by step, okay, what happened in the mechanism. So I'm going to start with um, a ketone, okay, the simplest one, a propanone. Okay, so I have C double bond O with 2 CH3. So this is a propanone. Now this carbon that is bonded to the O, because O is more electronegative, right? So O is partial negative here and the carbon is partial positive. Now in this reaction, the reagent used will be HCN reagent, HCN with a little bit of NaCN. Okay, now this NaCN is a catalyst. The cyanide ion from NaCN will kickstart the reaction. So the first step in the mechanism, okay, is the cyanide ion. Lone pair on the carbon. This whole thing is negatively charged. Now because the C has lone pair in the cyanide ion, so it will attack the carbon. Right? You know carbon can only form 4 bonds. We have 1, 2, 3, 4. Now it has to form a new bond with this carbon. So one pair of the electrons from the double bond will go to the O. This is the first step. Now we go to intermediate. Right? C now is bonded to 4 groups of atoms. The newly formed CC bond with the cyanide. Okay. Then of course CH3, the alkyl groups, they remain the same, no change. Now remember O, right? Now here double bond became single bond. Now, O now has 3 lone pair electrons. There's a negative charge. Okay, now HCN will come in, okay, in the second step. So let's draw HCN. The H is the partial positive one, right? This carbon and nitrogen, the partial negative N. So this O is negative. Okay, so the lone pair will attack the partial positive hydrogen in HCN. Now this bond will be broken with carbon taking both the electrons. So this is a heterolytic fission. Now, so what happened is carbon is still bonded to 4 different groups of atoms. CH3, no change. Now, I always write the one with no change first. CN also no change. So now O form a new bond with the H. And what happened is we get a new CN minus. Okay, so this is step 1. This one step 2. And this mechanism is nucleophilic addition. Okay, so what are the important things will be you must have the partial charges. You must show the lone pair. Okay, intermediate must be correct with the charge. Okay, arrows must be correct. Curly arrow, always use curly arrows. Arrows will always show the transfer of electrons, how electrons are moving. So lone pair to the carbon, Okay, this pair of electrons to the O. This one lone pair to hydrogen. Okay, bonding pair to carbon. Show the regeneration of the cyanide because cyanide is actually from the catalyst. Catalyst is not consumed in a reaction, so at the end it must be regenerated. Okay, so this is nucleophilic addition mechanism. Even if I replace this with an aldehyde, the steps will still be the same. You only change one of the alkyl groups to H.